All right, let's see if we are live. Am I live? Right? Looks like I'm live. All right. So I did one of this earlier, a long time back actually. This is basically me learning Python, messing around with Python, trying to learn and try and do something with Python. I have the link to the previous stream in the description, so you can check it out if you haven't seen it. There is no fixed agenda or preparation for these streams. If you've seen the previous one, it's going to be kind of very similar to that. I'm just going to learn Python, right, and make a fool of myself live on YouTube as I figure out this language. I am, as the title says, a Java developer. I come from a Java background. I have some JavaScript background as well. So I'm going to try and compare my learnings of Python with what I already know. And hopefully, it is not going to be too crazy and too different and too confusing. Last time went okay, it wasn't too bad. What did we cover last time? So we started out by looking at the official Python documentation, right? That's our source of learning Python. So this is what we used. We have the official Python docs. So this is literally docs.python.org. And we basically learned from this, right? So there is the Python tutorial, and it has kind of like an informal introduction. So we looked at the interpreter, we looked at data types, right? Numbers, strings, and lists. We looked at how to manipulate lists, and we looked at some control flows. We looked at the if statement, the for statement, and the very confusing else with the for, which is unique to Python, that kind of needed some wrapping around in our heads. So we did that. We looked at some other features like the range, break and continue. We looked at match, and we went to functions. We learned how functions are written. We learned how to pass arguments to functions, and we also learned about the two different types of parameters for functions in Python. We looked at the positional arguments and the named arguments, right? So with Java and JavaScript, we just have positional arguments. We don't have named arguments, but Python has named arguments and also default arguments. And we saw how we can create a positional argument and a named argument with the default value. And we also learned that the value for the default arguments are calculated at function definition time. See, Python is interpreted. So there is an interpreter which goes and reads through all the code. And at some point of time, it's going to hit this structure of the code, def, and it is going to be like, okay, now this has a default argument. Let's find out what the value is. Here it happens to be 5. So it is going to lock 5 as the default argument for this function f. And if you change I to 6 later and call f, what is going to be the value of I? It's going to be 5 because that's what it was when it interpreted this function. Okay. All right. So we looked at all those, and now we have keyword arguments. We saw how we can have positional and keyword, and we ran into one issue, which was like you cannot have a keyword argument before a positional. So the positional starts at the beginning, and then you have keyword arguments after that. So that's where we left off the last Python journey, and it's been way too long for Stream 2 because of some health issues. But here we are, onward. All right, so let's take a look at what's next. We have keyword arguments. Functions can also be called using keyword arguments in the form of keyword argument name equals value. We've kind of already seen that. In this example, we have a function called parrot, which is using def to define a function. It has a positional argument, which is voltage. It has 3 keyword arguments, which is state, action, and type. And they all have default values. So you can basically call this with just voltage and it should work, right? So, okay, so it accepts one required argument, voltage, and three optional arguments, which are state, action, and type. This function can be called in any one of the following ways. You can pass in just the voltage, positional argument, it's mandatory. You can pass the value to voltage as if it's a keyword argument. Interesting. So even though it is a positional argument, every positional argument is a keyword argument because you can say the argument name equals and value. This is very cool when you have a function with a lot of positional arguments, and then you're just stringing them along and you don't know what the function is doing, what these arguments are doing. So this is convenient that you can pass all these individual things and give it a name. So here you see voltage is this, action is womb. Okay, action is womb, voltage is this. And then here you have three positional arguments. So this is the converse, right? So you have a keyword argument can be treated as a positional argument as well, just in the position in which it is defined in over here. All right, cool. And then you have a mix of a positional and a keyword. But all the following calls would be invalid. Parrot would be invalid because it doesn't have the mandatory position argument. Voltage is 0.5, dead. Okay, dead is, wait, why is this? Non-keyword argument after a keyword. Okay. So the keyword argument has to be at the end, and it is defined by how you call it, not by how it is defined. Okay. These arguments. So basically, what I'm understanding is there's no difference between these arguments here. They happen to have a default value, but that doesn't mean that they're keyword arguments. These are all kind of at the same level. They're all the same thing. And it is how you invoke it, which is what makes it a keyword argument versus a positional argument. I hope my interpretation is correct. If any of you folks listening know Python, correct me if I'm wrong. Okay, so we got a duplicate value for the same argument, which is not possible. Okay, cool. And then you have a completely different argument, which doesn't even exist, so that's not cool either. Okay, cool. In a function call, keyword arguments must follow positional arguments. All the keyword arguments passed must match one of the arguments accepted by the function. Actor is not a valid argument for the parrot function, okay? So, and their order is not important. This also includes non-optional arguments, example, parrot voltage, which is valid too. Okay, it's non-optional, you can pass it as a keyword argument. No argument may receive a value more than once. Here's an example that it fails due to this restriction. Well, this was an example which failed due to that restriction. What is happening here? Okay, this is something similar. This is an even crazier example. Yeah, this is obviously not going to work. Okay. When the final formal parameter of the form star name is present, it receives a dictionary. Interesting. A dictionary containing all the keyword arguments except for those corresponding to the formal parameter. This may be combined with the formal parameter of the form star name described in the next subsection. Okay, this is confusing. What's happening here? So gsharp is a function. There are three arguments. There is kind, arguments, and keywords, but these are special arguments. So there is a star in the front, which is one type of argument. And there is a star in the front, which is another type of argument, which receives a tuple, whatever that's called. Receives a tuple, and star receives a dict. It's a very convoluted way of saying this. All right, let's crank open VS Code and we will write some code. Okay, so if you haven't attended the first stream, I should tell you my setup. What's happening here? I don't have Python installed on my machine, okay? I probably have Python from macOS. It kind of comes with Python, but that's not what I'm using, okay? And this is true no matter what your OS is. Setting up any desktop environment is a little tiring because you got to go install and all that stuff. What I'm using is Docker, right? I have a Docker image of Python, and you can easily spin this up by using the extension called dev containers. Okay, dev containers is a VS Code extension, and it allows you to just create containers easily. So you go and say dev containers, and here there should be there's an option to get dev test containers. Test containers. Yes, it's been a while. I've had some health issues, but I'm hoping to get back to the swing of things. So this one's one of those, like, it's been a long time. Let's see how it goes by just trying some Python. I was going to do Python on my own, so I thought, let me just stream it. Right. But yeah, it's coming up. It's all coming up soon. Hopefully, I'll be back to the swing of things. All right. So, man, where did that go? So you have a dev container. So there is a way in which you can spin up a new container, so new dev container, and you can start a new container here. All right, so you can see you have Python 3. You can create a new dev container, and it's going to download the Docker image, and you can just open it. So it's basically this is a Docker image that I have. You need to have Docker desktop installed though. So I have Docker desktop running over here. So you need to have that. But if you have that, you just get this dev containers extension and then just spin up a new Python container. So you don't have to go through the whole rigmarole of installing the SDK, all that jazz. So makes it very simple. So this is what I've got. I'm going to have a new Python file, which is functions test.py. All right, because I want to test this out. This doesn't make sense to me. So I have a function which takes in 3 types of arguments. One is just a positional argument. Another is a star argument, and the other is a star argument. Now let's see what this is. I'm going to have a def, which is a function, test function. Okay, so I'm going to have a positional argument, arg1, and then I have a star, arg2. This is it. Okay, I'm going to print arg1, and I'm going to print arg2. Okay, so now I will call test function with one argument, which is the number 1, and then another argument with the number 2. Okay, so I'm passing 1 to arg1 and string 2 to arg2. Now I'm going to run this thing, Python, and then functions test.py. So it takes the second argument as a tuple is what this means. It's basically, can I pass one more here? Let's say 3. Okay, now it makes sense. This is kind of like var args, variable arguments, right, in Java. So you basically have a multiple arguments being passed in, and it's going to basically collapse all of them. It's like everything else. It's almost like a wildcard, right? So it takes the first argument. The first positional argument is whatever you pass first, and then everything else after becomes a tuple. I guess that's what it's called. Yeah, it's a tuple containing positional arguments beyond the formal parameter list. Okay. Star name must occur before star name. Or let's look at star name and what that is. It receives a dictionary. Okay, so I have to do key value pairs. All right, so let's do star arg3. And over here for arg3, I'm going to have key value pairs. I'm going to have name, Kaushik, and then what else? Last name, whatever. And then foo 10. Okay, so now I have key value pairs here. So I'm assuming arg3 is going to contain a dictionary of these key value pairs. So let's see. Print of arg3. Does this work? No, that didn't work. I have to do equals. Okay, so it's not. I'm thinking of a like a JavaScript dictionary, so it's not. That's not the way it works. Okay, so this is equals. Equals. So it's almost like it's a positional. It's almost like it's a named argument here, right? Interesting. All right, let's do this. Okay, so now it creates a dictionary where the named argument is going to have the value, but when I'm passing it, it is like like a named argument. Interesting, interesting. So for the purposes of the execution, for the calling side, okay, over here in the calling side, there is nothing that tells you that this is going to a star argument or a star star argument. This is just, this looks like a named parameter, right? It's only over here that I'm able to map it to that thing, right? So when I do star argument, it is going to take everything that is not named parameter into that tuple, because this at this point it says, okay, this is a named argument, so it's going to go over here. Okay, now what if I remove this? What happens now? What happens now? Python, what you going to do, Python? It's going to give me an error. Okay, because name doesn't exist. Now, can I do a position, like a named argument over here? Name. Like this. What happens now? What happens now? So it's going to get, that's going to go to name. Okay. This should go as name. Okay, so this is cool because here an argument is either just an argument, just the value, or it is a named argument. But it's only here that it can, how you take it can change, which is pretty cool. Okay, so there's stuff you can do over here to change how you accept the argument that does not affect the caller, which I find pretty interesting. All right. Welcome back. Well, thank you. I'm glad to be back. It's been a while. It's been so long that I've forgotten a lot of stuff that I learned in the first live stream. So hopefully I don't make too much of a fool of myself. But if I do, so be it. Special parameters. By default, arguments may be passed to a Python function, either by position or by explicitly by keyword. Yeah, we learned it. For readability and performance, it makes sense to restrict the way arguments can be passed so that a developer need only look at the function definition to determine if the items are passed by position or keyword, or by keyword. Okay. A function definition may look like this. Position. What the heck is this slash? Slash, comma? Position or keyword, star, comma? What on earth is happening? Where slash and star are optional, if used, these symbols indicate the kind of parameter by how the argument may be passed to the function. Position only, position or keyword, and keyword only. Why do we need that? So this is like, I can put a slash and say from here on it's position or keyword, and after star it's keyword. Oh, I'm controlling how they can call. So this is the opposite of what I was praising Python for. Like I said, you can change all these things and the people here don't have to know. This is the opposite of this. So let's actually try this out. So I can say arg1, arg2, arg3, and then name. This is what we've got, right? Let's test this. It should work fine. Okay, I'm going to print arg3 as well, just so that we have it here. Okay, now I'm going to say arg3 needs to be, what was that? Arg3 needs to be keyword only. Okay, so I'm going to put a star here. This looks so awkward. star comma. Is that right? Yeah. So arg3 needs to be position, keyword only. Now what's going to happen? Aha. Take 2 position arguments, but 3 position arguments were given. Okay, so now I have to do, right? I'm the consumer. Now I have to do arg3 equals this. Interesting. Why do they have that? Why would you want to control how people are calling your function? Anybody has a good use case for it? Like, why would you do it? I'm curious. So let me know. And then slash is the same thing for positional. I'm not going to do that, but you get the idea. Okay. Keyword parameters are also referred to as named parameters. Okay. If slash and star are not present in the function definition, arguments may be passed to a function by position or keyword. Yeah, we kind of already landed on that. Okay. All right. Position only parameters. Looking at this in a bit more detail, it's possible to mark certain parameters as position only. If position only, the parameter's order matters, and the parameters cannot be passed by keyword. Oh, so if it's named, then the order doesn't matter, huh? So what if I do this? I'm guessing it's going to work. It's going to work? Yeah, 1, 2, 3, and my name. Interesting. Okay. All right. So if I have position only, then obviously the position matters. Duh. Where was I? Parameters cannot be passed by keyword. Position only parameters are placed before a slash, a forward slash. Does Python have default arguments values? Yes, it does have default arguments and values. That is by just putting the equals in the front. So you have something like this, right? So name. I want it to have a default value. So I'm going to say name equals foo. Okay, and now I don't have to give name. And skip this thing. It is going to take foo as the argument. See, so it's kind of like TypeScript. I'm used to TypeScript, and it's very similar to that. Okay. Okay, position arguments are placed before a forward slash. The forward slash is used to separate position from the rest of the parameters. If there's no slash, there are no position only parameters. Okay. Okay, which means, if we don't have the slash and the stars, then anything can be used as anything, which is cool. All right, keyword only, mark parameters, keyword only. We did a star. Well, yeah, we already covered this. Okay. Consider the following example. Paying close attention to the markers slash and star. Right, let's pay close attention, folks. So I have a slash here, which is useless because this is doing nothing. There's nothing following it. Right? There is a star arg, which means that arg has to be keyword argument, right? And you have a slash and a star here, which means that this can be position or keyword. Since it's a slash, this is position only. And since there's a star here, this is keyword only, right? The first function definition, standard arg, is the most familiar form. Places no restrictions, and you can do both. The second function, position only argument, is restricted to only use positional parameters, as there is a slash in the function definition. But shouldn't it be before? Isn't that what they say? Like, it has to be before, right? Parameters following the slash may be position or keyword only. Position only parameters are placed before a slash. Okay, now I'm confused. When you have a slash after, that means that the arguments following the slash are position only. No? So we can just try it out. Simple, right? I'm going to put a slash here. I can't put a slash in the beginning. Oh, it has to, okay. Okay, so let's do arg1 and then slash and then arg2, which means that arg2 is now position only. So this is going to work, but I cannot do arg2 equals this. It is going to fail. Why? It still worked. All right, I'm gonna have to, I'm gonna have to read this. This is confusing. Okay, so before the slash is position only. After the slash, okay, after the slash is position or keyword. So when the slash happens, the things before the slash become position only. Now it makes sense. All right. Things before the slash become position only. So now I cannot do this. arg1 equals. This is going to fail, right? Okay, now I follow. Now I follow. Do you follow? Now I follow. If the slash doesn't exist, anything can be anything. But when the slash exists, what's before the slash is position only. And what's after the slash still has the same, the anything goes. And the star on the right side. That was confusing because for the slash, what affects is what's on the left of the slash. And for star, what affects is what's on the right of the star. Okay. Okay. How are you folks doing, by the way? It's a Saturday evening here. You folks doing good? Everybody having a Sunday morning now? Okay, the position only, okay. Slash, all right. All right, keyword argument, okay, that star makes sense. And the last uses all the three conventions, okay. Cool. Finally, consider this function definition, which has a potential collision between the positional argument name, and the keywords, which has name as the key. So this one is a positional argument and can be a keyword argument as well. And then you have keyword star. So it's going to get a dictionary. Now I'm passing name. Oh, okay. Now when you pass name, what's going to happen? So you have one going to name, but then you have name colon. There is no possible call that will make it return true, as the keyword in name will always bind to the first parameter. So when this happens, name will always bind to the first parameter. Name will bind to this, right? How would it return true? It returns true if name exists in keywords. So it'll never exist in keyword because name will, okay, this will bind to the first parameter. Okay, but using position only arguments, it's possible since it allows name to be a positional and name as a key. Now I get it. When you put a slash here, that means that name is now position only. So if you have name passed in as a key, it has to map to keywords. All right, let's try this out. So I'm going to make this simpler, or maybe create one more. Def test function 2. Okay, so I have arg1, arg2, and I'm basically going to print these two. And now I'm going to call test function 2 of, let's do the simple one, arg1 equals 1, and then arg2 equals 2. So this is obviously going to print 1 and 2, simple. Okay, now I'm going to make this a keyword argument. Okay, this is kwd. And now kwd. So this is not going to break anything. arg1 is going to go to arg1, and then arg2 is going to go over here. But if I were to make this positional, and I were to make this as, so this is going as a dict, right? arg2 equals 2 is going as a dict to this kwd. Now if I were to make this arg1, oh no, actually let me go one step at a time. So I have positional argument going to arg1, and arg2 equals 2 is going to this because of the star. So fine. Now if this were arg1, then I get multiple values for arg1. Okay, so now if I were to say arg1 is going to be only positional argument, then it works. Okay, then it is going to say this has to be arg1. When you have a named argument, it cannot possibly be to this thing because there is a slash here. This has to be positional. So it means that this has to go to this. Okay, now we found a use case for the slash. Well, it's a little bit hacky. I don't know if there is like a real world use case for this, but at least it makes sense that it is there. All right, recap. The use case will determine which parameters to use in the function definition. So you have position, then a slash. The slash means that these two are position only. This is position or keyword, and then there is a star, and then keyword. Okay. As guidance, use position only if you want the name of the parameters to not be available to the user. This is useful when parameter names have no real meaning. If you want to enforce the order of the argument when the function is called, or if you need to take some positional parameters and arbitrary keywords. Okay, so when the name doesn't matter, or when you have like a bunch of them, then you use position only parameters. Interesting. Use keyword only when the names have meaning and the function definition is more understandable by being explicit with names, or you want to prevent users relying on the position of the argument being passed. Okay, then it has meaning. For an API, use position only to prevent breaking API changes if the parameter's name is modified in the future. Right. Now, what if it's just one? So, for example, I have this break message, which I wrote in the last live stream. It shows like, okay, we're going to take a break from the live stream. It's going to just print number of seconds, right? It takes the total number of seconds, and then it just says starting stream in, and it does a countdown. Okay, simple program. Now, should I do keyword only for this? Like if I have to do keyword only, I have to do this, right? I have to do star and then this. So I can either let me verify this once just to make sure my understanding is right. So this is going to work. Or I do, okay, stop. Or I can do seconds equals, I don't know, 200. But I cannot make this position only, right? This is going to work, but I cannot say seconds of 200. This is not going to work, right? Yeah, it's not going to work. So when I have something like this, just one argument, and the meaning does matter, because when I'm saying show break message, I'm saying, okay, what am I passing? Show break message of 200. What does it mean? Is it the font size of the break message? It's ambiguous. So I guess in that case, it makes sense to say seconds equals 200. So should I do this? I'm guessing that's a yes, but yeah, we will see. I think that's what this seems to be saying. But it's also an API. Could potentially be an API. So I don't know if it's yeah. I don't know. We'll see. All right. Arbitrary argument list. Finally, the least frequently used option is to specify that a function can be called with an arbitrary number of arguments. These arguments will be wrapped in a tuple. See, tuples and sequences. This tuple is coming up again and again. I think that's coming up next. So we'll hold that thought. Right? We want to learn about tuples and sequences. Before the variable name number of arguments, 0 or more normal arguments may occur. Yeah, we already covered this. Why are they saying this again? Yeah. Star is varargs, the Java varargs. You just say star at the very end. It basically catches all and puts it into a tuple. We don't know what a tuple is. It's not an array, I'm guessing, but we'll find out. But variable arguments. Normally, these variadic arguments will be the last in the list of formal parameters because they scoop up all the remaining input arguments that are passed to the function. Any formal parameters will occur after star args, which occur after the star args parameter are keyword only arguments, meaning that they can only be used as keywords rather than positional arguments. Ooh, is that what the star is here? Ah, interesting. So this kind of like variable arguments, but it's not capturing anything, which is star. Is that what it is? So that makes sense. So here you have a star thing. So it's like capture something, but it is also a star, which means that anything after this is a keyword only argument. But this one's a star without capturing anything, but still anything after this is keyword only. Makes sense. Makes sense. All right. Okay. We have that. And we have the capturing, the varargs, and the keyword only. Is that what we call vararg? Can we call it a varargs? Is something else? Is it arbitrary argument list? Is that what it's called? Come up with a better name, Python. Varargs is so convenient. Okay. So you have concat of args and then separator. Okay. Cool. Nothing new. We've covered all that so far. Unpacking argument lists. The reverse situation occurs when the arguments are already in a list or tuple, but need to be unpacked for a function call requiring separate positional arguments. Okay, so this is the opposite. For instance, a built-in range function expects a separate start and stop arguments. If they're not available separately, write the function call with the star operator to unpack the arguments out of a list or a tuple. Ah, so it's the opposite. It's the other way around. So I can put a star in the caller, so it unpacks over there. So star is an unpack. If you put a star in the function, then okay, over here. If you put a star in the function definition, it unpacks over there. If you put a star in the function invocation, it unpacks in the invocation. Interesting. All right, let's do one more. I'm going to say def test unpack, and then I have first I'll have a arg. So I unpack over here, print of arg, and then I do test unpack of 1, 2, 3. And now this is basically going to take all of that and no, not this one, functions test. So I get 1, 2, 3, right? However, if I have 3 arguments, arg1, arg2, and arg3, and I want to pass a range, right? Test unpack of range of, let's say, 1 and then 3. Okay, so it's going to do 1, 2, and 3. But now I cannot pass this. This is accepting 3 separate arguments. So what I'm going to do is I'm going to unpack over here. I'm going to say unpack it. Does this work? No, that didn't work. Missing 1 positional argument. Wait, range of 1, 3. I forgot what range does. What does range do? Let's see. Range, start and stop. Oh, I just need to say how many I need. Okay, so I just need 3. That was my mistake. So it's going to do 0, 1, and 2. Okay, so starting and the length. So I'm going to say start from 1, and then I want 3. So this would go 1, 2, and 3, right? Why not? Range, start and stop. Oh, start and stop, not start and length. So this is going to be 4. Okay, the end exclusive. Okay. So this is 2 ways in which we can pack and unpack, which is kind of interesting. Just interesting. What do you folks think? Let me know in the comments. Let me know in the comments. Any of you here a Python expert? Let me know in the comments. I might ask you questions if I don't understand. All right. Stop is non-inclusive. Yes, yes. Thank you. Thank you. For some reason, you were in my recommendation. Hello. Well, YouTube knows best because YouTube is awesome. It uses AI, and AI is always right, as you might have heard from the news. So if YouTube is saying that you need to watch this video, well then you don't have a choice, do you? All right. Stop is non-inclusive. Thank you. Yes, I learned it now. It makes sense. So I was thinking of it as length, and it's obviously not length. So this is packing and unpacking. Cool. Next, lambda expressions. Really? Python has lambda expressions? Well, I'm a Java developer. I know a little something about lambda expressions. Let's see how different Python's lambda expressions are. Small anonymous functions can be created with lambda expressions. This function returns the sum of its two arguments. Lambda a comma b returns a plus b. Okay, you need to literally have lambda to define a lambda expression. Interesting. Lambda functions can be used wherever function objects are required. They are syntactically restricted to a single expression. Remember function objects from last time. Functions are first class citizens in Python, just like JavaScript, right? You can take a function and assign it to a variable, right? When Python is like looking at this thing, right? It's creating a symbol table, right? Each scope results in a separate symbol table. So when it's running this thing, test function is a symbol in the symbol table. Test function 2 is another symbol in the symbol table. So you can say, I don't know, create a new variable called foo equals test function, and that is fine. So this is first class status for functions. So lambda is one of those things, is what they're saying. All right. I just watched your Spring Microservices tutorial. Well, thank you so much for watching. Now I'm learning Python, and maybe a couple of hours I'll start making a Python tutorial as well. Just kidding. I'll need a little more time. Maybe a year from now. Who knows? Python is supposed to be easy, so maybe I'll be making a tutorial the next month. So stay tuned, subscribe, and hit like and all that good stuff. All right. So they're syntactically restricted to a single expression. What? Syntactically restricted to a single expression, so you cannot do like a bunch of lines? Weird. Semantically, they are just syntactic sugar for a normal function definition. Like nested function definitions, lambda functions can reference variables from the containing scope. Okay, so it's pretty much equivalent to having a definition there. So you have a make incrementer, takes in one argument, n, and it returns a lambda, which takes an argument and then adds n to it. So I say make incrementer 42, and I'm going to get back a lambda which adds 42 to whatever you pass in. So I pass in 0, I get 42. I pass in 1, I get 43. Okay. The above example uses a lambda expression to return a function. Another use is to pass a small function as an argument. Pairs. So I have pairs of values 1, 1, 2, 2, 3, 3, 4, 4. Pairs.sort key equals lambda pair of 1. Ooh, it's pulling up the key. It's kind of like doing a map in Java, but we're not doing streams here. It's mapping each individual value to the thing that needs to be sorted. So in this case, you want it to be sorted by pair of 1. So it is going to be the string, and it's going to sort by the string. Okay, cool. Well, that's it for lambdas. This is a short section. Is that all that lambdas can do? There's a link here. Let's check it out. lambda are used to create anonymous functions. The expression lambda parameters expression yields a function object. That's it. Odd. There's so much for lambdas in Java. Seems simple enough. Let's actually do a lambda, okay? We will write a lambda and then we'll call it just to test this out. Lambda.py. Right, so I'm gonna have so lambda is basically, they say it's a function object. So can I say my fn equals lambda? I have to put lambda colon lambda and then the value x colon x plus 1. So this is a lambda. It's funny that you gotta write lambda here and they say Java is verbose. All right, so now I'm going to call my function of 1. This should return 2, right? Yeah. Python lambda. Okay, so that's a lambda expression. Where have you been? I have been. It's been a while, hasn't it? It has been a while. Yeah, I was not well. I was not well. Sorry, I had a bunch of cold. I got COVID. It was a mess. So I was away on health issues for a while, but here I am. Okay, documentation strings. Here are some conventions about the content and formatting of documentation strings. The first line should always be a short, concise summary of the object's purpose. Oh, they're talking about conventions here? Okay. Okay. All right. This is how you have to write documentation strings, guys. Watch out. For brevity, it should not explicitly state the object's name or type since they're available by other means, except if it happens to be in a verb describing the function's operation. This line should begin with a capital letter and end with a period. Oh my goodness. Okay. If there are more lines in the documentations, I just find it funny that they're mentioning this in the language guide. Imagine if Java has in the official Java documentation, Java docs should begin with a capital letter. I don't think that would be very popular. Okay. Okay. More lines. The second line should be blank, visually separating the summary from the rest of the description. The following line should be one or more paragraphs describing the object's calling convention, its side effects, etc. Okay, so you have my function do nothing but document it. No, really, it doesn't do anything, and then it passes. Oh, you can do function dot underscore underscore doc underscore underscore. Really? I didn't know that. Okay, so this gets the doc string. Interesting. Let's try it out. I'm going to put function test here. Unpack. So what does this do? How do I have to do this? Okay, first 3 quotes. There's a doc string, right? And the first line has to be a brief description. Prints the args passed in. Okay, and it should end with a period, right? End with a period. Okay. Am I following all the rules? Okay, I'm following all the rules. All right. And then description. Just prints it. I don't know. All right. So now here I'm going to print. So this is the function object, which is test underscore unpack dot. Oh, look at all the stuff that we get for this function object. Annotations, built-in closure, doc. All right, let's print the doc. Python functions test. Okay, so it prints this. Do Lambda expressions have that? Can I do print my fn dot? What is the default doc? I'm guessing it's going to be empty. Lambda. It is a none. Aha. None is the null, equivalent of null in Python. So by default, it is none. All right, now I'm curious, what else can we get from function? I'm going to do a dot. All right, closure. dir, doc we saw. What is dict? What is this going to do? Again, that's a none. All right, I'm not going to mess with this. We'll see. We'll get to it later. I think we might have to write a function a certain way so that those things have a value. We'll get to it later. All right, underscore underscore doc underscore underscore. So this underscore underscore format is what's referred to as dunder in JavaScript. Okay, you have a bunch of dunder variables. I think it's named after the Dunder Mifflin, whatever is the name of the company in the Office TV show. I have a feeling Dunder might have happened before, but either way, whatever name comes first, this is referred to as dunder. Okay, and a lot of the prototype related stuff in the JavaScript object has this format. It has underscore underscore format. So it looks like Python has something similar, underscore underscore doc. Okay, function annotations. Function annotations are completely optional. Metadata information. All right, we have comment. What a pleasant surprise to see you live. Really enjoyed your Lambda tutorials. Thank you, thank you. I hope you love my my Python, messing around with Python. You know, you said Lambda tutorials. Let me show you. Let me show you the Lambda section in Python. I'm learning Python now, okay? And here's a Lambda section for Python. From the official doc. This is it. Do you know Python, Zach? This is crazy. I was just, you know, there's so much to lambdas in Java, and this is it for Python. It's crazy. Okay. Function annotations are completely optional metadata information about the types used by the user-defined functions. I think PEP here refers to like something like JPs, right? These are suggestions for, Python enhancement proposals. It's similar to JEP, Java enhancement proposals. So it kind of like this introduces features to the language, and it probably has a good coverage of what those features entail and how they're used. At least like the behind the scenes thing for those features. JEPs are really interesting to read as well, by the way. If you're a Java developer, you should check out some of these JEPs. They go into a lot of detail about why the feature was introduced, which is always interesting to learn. All right, I'm not going to go look at that now. Annotations are stored in the underscore underscore annotations attribute. We just saw this. This is the dunder attribute of a function as a dictionary and have no effect on any other part of the function. Parameter annotations are defined by a colon after the parameter name. Okay, followed by an expression evaluating to the value of the annotation. Return annotations are defined by a literal arrow followed by an... Wait, what is an annotation? Hang on. Wait. What's happening here? What is an annotation? Are completely optional metadata information about the types used by user-defined function. But what do they do? Parameter annotations. Just I can put anything there? Is that what it means? So here str is an annotation because you don't have types here, right? Python doesn't have, you don't define types like this. It's basically saying it's str. Is that what it is? Let's actually try this out. Can I like stick any crap here? Foo. seems like it works. Okay, let's do underscore underscore annotations. Let's print this out. Not lambda functions. Name foo is not defined. No, that's not how it works. So what is an annotation? I still don't get it. Parameter annotations are defined by a colon after the parameter name followed by the expression followed by an expression evaluating to the value of the annotation. Ah, I see. So shall I do this? A string. Would this work? There you go. That works. So basically any expression. So I can say arg1 is going to be 1 plus 1. And it is going to have, the annotations object is going to have here arg2, and the value is 2. There we go. So that's annotation. So I can stick any random crap in there. It has to be an expression. Okay. So for parameter annotations, I just put a colon and then the annotation. And for methods, for return, annotations are defined by a literal arrow. Okay, I'm guessing it's used for types. So it's you can kind of, the best way to define types here in Python. So I can have arrow and then 100 times 2, for example. Now this is going to have, for the return, the value is going to be 200. What is it going to have? Okay, the key itself is return. Okay, got it. So these are annotations. What are the common applications where Python is preferred over Java? Well, AI is the first thing that comes to mind. All of the AI work and even the data science work was mostly happening in Python, because most of the people working on those libraries, at least the initial people working on those libraries, were not programmers. So they just picked the easiest language that they could grab, and it happened to be Python. Oh, I got a super chat. Well, thank you so much. Thank you so much. Your courses are awesome. Quick question. As a deck, can we write good code, but how do you write good code when using design principles? Huh? Hang on. Let's see. I don't quite get it. Quick question. As a deck, we can write good code, but how to write good code using design principles? Can you teach us that? The way to write good code is not following design principles for some arbitrary rules. The way to write good code is to think about your fellow developers, to think about how the application is going to evolve in the future, and write it in such a way that it's easy to read, easy to maintain, and hopefully easy to evolve. That's the way to write good code. Like if you look at like a guidebook and say, okay, here are the design principles, I'm going to use this to write good code, it's usually not going to work, because you're usually going to shoot yourself in the foot doing something that you wouldn't normally do just because the book says it. A lot of writing good code is not just about learning the rules, but also about knowing when to apply what rules. And that comes from experience and reading other good code. I would say don't worry so much about reading design principles. Look at well written code and try and understand why it was written that way. That's going to probably give you a lot more. Can we use Django for backend development? Sure, why not? Django is like it's like a backend web application server for Python, isn't it? I think so. Okay, I have sorry, I didn't see a couple of questions here, but yeah, str is syntactical shortcut for document. Yeah, this has to be an expression, right? Whatever I put here in the annotation has to be some expression. So it's just for documentation. I'm guessing types would be a good way to good thing to document with these things. So that makes sense. Why Python is preferred over Java for AI? Again, like I said, here's my theory. Okay, I don't know if this is really why it happened. My theory is when I see the blinds, my window blinds are making this really cool pattern here. Really cool pattern on the green screen. It's kind of nice. I didn't do this. This is literally like sunlight. Can you see this? It's literally sunlight coming from the blinds. Very cool. Why is Python preferred over Java? Because right now, Python is preferred over Java because of the momentum. It's like there are more libraries written in Python for AI, so people choose Python for AI. But the real question is, Why did it become that way? Why did it end up being more libraries in Python? And my theory for this is the initial set of people who wrote those data science and AI libraries weren't pure programmers. They were scientists, and they needed to write it in some language. And Python has a reputation of being the easiest language to learn and write code in. So those people said, okay, well, let's pick the easiest language and get this thing done so that we can move on to do more scientist stuff. So I think that's why it ended up being that way. Dependency injection complications are the reasons my company is choosing Python for the most part, as it takes a while to dig through errors in Java. I don't think so. Yes, it's you usually trade off complications. You get new complications when you switch to Python. It's I don't know about that. Dependency injection isn't really that hard. All right, let me see if I can close the blinds fully. No, looks like I cannot. All right, we'll have to live with that. The fancy graphics caused by the sun. It is it's 6 o'clock here, and the sun is setting on the side. That's what you're seeing. All right, let's move on. We're learning Python, guys. We're learning Python. Let's move on. And I mentioned this in the last stream as well. Don't talk about Java going away and people are switching to Python because I'm learning Python. I'm not stopping Java programming. I'm just learning it for fun and for doing some cool stuff. It's always good to learn. All right. So we covered this. We covered annotations. So annotations are useful for documentation, and you can basically stick anything in there. It has to be an expression, and that's it. Okay. Now, intermezzo, coding style. Now that you are about to write longer, more complex pieces of Python, it's a good time to talk about coding style. Most languages can be written or more concise, formatted in different styles. Some are more readable than others. Tabs versus spaces, anybody? Making it easy for others to read your code is always a good idea. See what I just told you. And adopting a nice coding style helps tremendously for that. For Python, Pep 8 has emerged as a style guide that most projects adhere to. It promotes a very readable and eye-pleasing coding style. Every Python developer should read it at some point. Here are the most important points extracted for you. Pep 8. Okay, so this is Python enhancement proposal number 8. Interesting. Use 4 space indents and no tabs. Okay. They've resolved the see, problem solved. Tabs versus spaces, resolved. Next, we're going to go for world peace. Okay. 4 spaces is a good compromise between small indentation, which allows greater nesting depth, and large indentation, which is easier to read. Tabs introduce confusion and are best left out. Okay, tabs versus spaces, solved. All right, one more super chat. All right, let's take a look at this real quick, and then we're gonna move on to Python. Okay. One last question. Topic args in US. Do we expect it to recover? Topic args in US. Do we expect it to recover anytime soon? What's your take on the same? Also, tech like Chat, GPT, and Bard. How does it impact the future of developers? I honestly didn't understand the first part of the question. Games. I can answer the second part. How does it impact the future of developers? Well, right now nobody knows, but at this point, they say about how the AI curve, right? So there's a typical adoption and technology maturity curve for any technology. It goes something like this, right? There is slow adoption, and then there is rapid improvements because everything is building on top of each other, and there is rapid progress. And then after a point, it reaches its potential, and then it's going to slow down. Okay, and how AI affects us really depends on where in that curve we are. Are we still in the beginning and the rapid advancements are still to come? Or are the rapid advancements already happening? Or are we in the middle, right? We don't know where in the curve we are. If we are in the beginning, then who knows what's going to happen? Humans might become obsolete, let alone programmers. If we are at about the end, well, our jobs are pretty safe. They're not going anywhere because if you played with ChatGPT, you will know that it does some of the basic stuff very well, but it doesn't do some of the other stuff. But it depends on where in the curve we are. Okay, that's what I think, and it's also the thing that ChatGPT is going to become a tool that developers are going to use rather than it replacing developers, because a chat GPT plus a human is always going to be better than just chat GPT. So we will have developers. We'll probably be expected to perform a little faster, but we will be able to perform faster because we have chat GPT. That's what I think. And about layoffs, it's a cycle, my friend. We've had layoffs and the economy has recovered, and we had layoffs again and the economy has recovered again. I've been in this industry for 22 years, 23 years now, and this thing keeps happening. So we're just about hanging tight when the layoffs do happen, and about being good at your job. That's going to tide you over a lot of these ups and downs. If when the times are good, everybody prospers. And when the times are bad, only the skilled and talented prosper. So let's all try and be skilled and talented. I'll leave that question with that. All right. I think there's going to be more people working on things, more people building things, because it's going to be faster. So there's going to be more. I think there's going to be more work. You're right. Okay. Let's continue. Wrap lines so that they don't exceed 79 characters. They're talking about lint rules here. This is so crazy. There was a section which talks about documenting functions, and that the documentation, the first line has to begin with a capital and has to end with a period. And now they're talking about linting rules. It's so weird to see this kind of stuff in a beginner tutorial. Oh, well, maybe this is important in Python. Use blank lines when separating functions and classes, larger blocks of code. If when possible, put comments in a line of their own. Use docstrings. Use spaces around operators and after commas, but not directly inside bracketing constructs. Okay, name your classes and functions consistently. Convention is to use upper camel case for classes, lowercase with underscores for functions and methods. Always use self as the name of the first method argument. Okay, they're talking about methods, and we haven't covered methods yet, so we will look at that when we get there. Don't use fancy encoding if your code is meant to work in international environments. UTF-8, Python's default UTF-8, or even plain ASCII work best. UTF-8 is really the best way to go. Don't use non-ASCII characters and identifiers. If there is only the slightest chance people speaking a different language will read or maintain the code. Okay. Is this clear, folks? Are we good? We now have learned about functions. We've learned about lambdas. We learned about positional and named arguments. And we learned about what else? What else did we learn about? We learned about how to write comments, unpacking and packing argument lists. We learned about what is this? There were two types, right? One is you take it as a tuple, and the other takes it as a dict. So we learned them both. Awesome. Let's move on. Next. Data structures. All right, I'm going to do a break. It's been an hour since I started, so I'm going to do a break, and we will continue after the break. And I have just the Python program for our break. Here's a break message program that I wrote, and this is going to give us a countdown. Okay. Oops, not what I had in mind. Now here, I'm going to... This is time in minutes, so this is going to be... Let's take a 10-minute break, and then we will resume. Okay, so this is Hang on a second. So first of all, this should be second. Oh, this is seconds. Okay, so this is going to be 10 times 60. Yeah, okay. And I'm going to run. Okay, go away, App Store. Thank you. Ah. Okay. Let's take a break. Break message. All right. We're going to start the stream resume the stream in 588 seconds. See you folks in a bit. I hope you folks had a good break. We are going to continue our exploration of this language called Python. Let's take a look. We're going to look at data structures now. Okay, data structures. This chapter describes some things you've learned about already in more detail and adds some new things as well. Okay, we would ideally like that when reading a tutorial, so good job. More on lists. The list data type has some more methods. Here are all of the methods of list objects. All of the methods? Okay, let's look at them. List dot append. We've already seen this. You can do append, basically adds at the end of the list. This is equivalent to going over here at the end and saying creating a new list with that element and saying put it at the end, which is what this length of the list colon means. It's going to the end. List.extend of iterable extends the list by appending all the items from the iterable equivalent to a of length as equals iterable. Extend the list by appending all of the items. Okay, so it's basically going to take all of the things in the iterable and then stick it there. Okay. Insert. Oops, what happened to this thing? All right, give me a second. I am resizing the wrong thing. Come on. All right. There we go. Okay, let's go here. So append adds to the end. Extend basically adds an iterable to the end. It's basically how many of our elements there are. Insert inserts in the middle, at some point in the middle, given a position. Remove removes the first item from the list whose value is equal to x. It raises a value error if there's no such item. Okay, so this is our first mention of errors in Python. We haven't looked at exceptions or errors or whatever it's called. So there seems to be a built-in exceptions page where we will learn all about it. We're just going to move on. We just assume that Python has some way of throwing errors or exceptions, and it just happens. So in this case, when you do a remove, and the thing that you want to remove doesn't exist, it raises a value error. It raises, not throws. Maybe that's the name used here. Okay. There's remove, there's pop. Remove the item at the given position in the list and return it. If no index is specified, a.pop removes and returns the last item in the list. Okay, so it's kind of like a stack data structure, right? You just pop at the end. It's similar to JavaScript. JavaScript has a pop as well. So this is confusing because I kind of thought like, so this is square brackets to indicate that it's an optional argument. Okay, so if no index is specified, it removes at the end. And if it is specified, it removes it at that position. So it's kind of like remove, but if you don't specify anything, it becomes a pop. Clears all the elements. Clears all the elements equivalent to del of without position, just the colon, which means from beginning to the end. Something if you haven't seen the first stream, so you can put a colon here to indicate like a range, right? If you specify 1:3, it means from 1 to 3, or I don't remember if it includes or excludes 3. But the point is, if you don't specify the number, you're basically saying from the beginning to the end, right? So if we say nothing here, just :3, which means 0 to 3. Okay, so when you say 2, 2 : and then you leave the second number as blank, that means 2 to the end of the list. So here you've left both as blank, which means from the beginning to the end. List of index. List.index returns a zero-based index in the list, the first item whose value is equal to x. raises a value error if there's no such item. Okay, it's kind of like index off in Java. The optional arguments start and end are interpreted as in the slice notation and are used to limit the search to a particular subsequence of the list. The returned index is computed relative to the beginning of the full sequence rather than the start argument. Ah, I see. You're saying look at only this portion, but then the index is going to be for the whole thing, right? I think Java does it better because there is a separate API call for getting the subsequence for a list, and then you can do find on top of it, like index off on top of it. So it kind of makes it simple. Here, they're basically overloading individual methods with this extra thing, which is like, I don't know, do you really need it? But it is what it is. List.count returns the number of items X appears in the list. Okay. Sort the items of a list in place. The arguments can be used for sort customization. See sorted for an explanation. So sort of star. What's star? Key is none, and reverse is false. Okay, so it's for certain, ascending or descending order. I would say reverse is true if you want descending order. Fair. Key is none. So key is we saw one example earlier about how they were sorting like a bunch of tuples, and they had a lambda passed in for the key. So they could say, okay, find this particular position for the tuple and then sort based on that. So that explains the key. I don't understand what star is here. Returns a new, so it's an iterable, sorted of iterable. No, that's different. Sort. Let's actually test this out, right? I'm going to test this out. So I'm going to create a new file. I'm going to call this data underscore structures.py. All right, so I'm going to have a numbers equals okay, so I have something in non-sorted order. Why am I sticking a semicolon here? It's a bad habit. Okay, now what I need to do is sort it, right? Can I say numbers dot sort? Will this work? And then I'm going to print numbers. What is this going to do? Python data structures. Okay, so it's sorted based on this. Okay, now I'm going to get the key, and then let me say the key. What is the type of the key? I don't know what the type is. What if I just do 1? So does it assume that it's always sorted? Oh, I used it for print. Okay, so I have to do sort, and then I'm going to pass in 1. It's probably going to complain because it doesn't find it. So what? I don't understand what star is over here. Listed star, sort of star. Sort the items. So it says go look at sorted, but sorted seems to be a different thing. Or maybe it's the same thing. Returns a new sorted list from the items in the iterable. So this is when you pass in the iterable. I don't need to pass in the iterable, right? Because this is numbers dot sort. I have to figure out what this is. What is the arg to sort? All right, I'll try and figure this out and maybe post back in the comments. If any of you folks know, let me know. List.reverse reverses the list. Okay, list.copy returns a shallow copy of the list, which is equivalent to basically that wildcard thing. Okay, an example that uses most of the list methods. So you have a list of string, fruits.count of apple, says how many times apple was occurring in the list. Fruits.count of tangerine, 0, because it doesn't exist. Index of banana finds the first index, 0, 1, 2, 3. So the return is 3. fruit star index of banana comma 4. Find the next banana starting at position 4. So it's going to go over here and it's going to find this guy here. Okay, interesting. Fruit start reverses the list. Okay, it's reversed. It's modifying it in place. Fruit start append of grape adds grape to the end. Fruits dot sort, it's going to sort it, and dot pop is going to remove the last element, which is pair in this case. Okay, you might have noticed that methods like insert, remove, or sort that only modify the list have no return value printed. They return the default none. This is a design principle for all mutable data structures in Python. That's good to know. That's good to know. It's not so for Java, for Java collections. Even if you're working on a mutable data structure, the operation sometimes returns a value. Okay, so for example, set, it returns a boolean whether whatever you inserted did actually insert or not. But it looks like there's a design principle in Python where if you're modifying the thing itself, it's not returning anything back. It returns none. It's an interesting choice. They could have returned something which indicates something about the operation, but they said no, we won't. Okay. Another thing you might notice is that not all data can be sorted or compared. For instance, none hello 10 doesn't sort because integers can't be compared to strings, and none can't be compared to any other types. Also, there are some types that don't have a defined ordering relation. For example, 3 plus 4j is less than 5 plus 7j isn't a valid comparison. What? 3 plus 4j is less than 5 plus... What even is this thing? I don't know. Using lists as stacks. The list methods make it very easy to use a list as a stack, where the last element added is the first element retrieved, last in, first out. To add an item to the top of the stack, use append. To retrieve an item from the top of the stack, use pop without an explicit index. So it is going to, which makes sense. Append always adds to the end, pop always removes from the end. So if you're using append and pop, you've got a stack. Cool. Using lists as queues. It's also possible to use a list as a queue. Well, you just have to change one operation. So append adds to the left, append adds at the end, and pop left is the method that removes from the front. Okay. Okay. So in JavaScript, it is shift. With in Python, it is pop left. Okay. When appends and pops from the end of the list are fast, doing inserts or pops from the beginning of a list is slow because all of the other elements have to be shifted by one. To implement a queue, use collections.deck, which was designed to have fast appends and pops from both ends. Okay, so they have a deck too, just like Java collection framework has a deck. Interesting. I wonder if they are using linked lists as well, backing the deck, because Java decks use, linked list is a common implementation choice for decks. Okay, from collection, import deck. All right, we're going to do an import here. They just threw that in, by the way. We haven't covered imports in Python, but I'm hoping that's coming afterwards. So basically the idea is you get something from another module and you can use it. You bring it to your namespace. So q equals deck of 3 strings, dot append, dot pop left, dot pop left. Okay, so this is how you can do queues in Python. Okay, list comprehension. Oh, I've heard of this thing. This is funky syntax, guys. This is funky syntax. All right, are we ready? Are we ready for list comprehension? For comprehending list comprehension, let's do this. This is I've seen this. I know this exists. It's time I encounter it and tackle it. All right, let's do this. List comprehensions provide a concise way to create lists. Common applications are to make new lists where each element is the result of some operations applied to each member of another sequence or iterable. or to create a subsequence of those elements that satisfy a certain condition. I didn't understand any of that. Let's read that again. Common applications are to make new lists where each element in is the result of some operation applied to each member of another sequence or iterable, or to create a subsequence. So when you want to do a map, take each element of a collection and make another collection. Or if you want to create a subsequence that satisfy a certain condition, you want to do a filter, then I guess you do list comprehension. Okay, when you do need to do a map or a filter, do list comprehension. Okay, for example, assume we want to create a list of squares like this. I have a list of squares, and for x in range of 10, I want to do x square, right? So squares of 0 to 9. And I'm going to get all the squares of 0 to 9. Note that this creates or overrides a variable named x that still exists after the loop is complete. We can calculate the list of squares without any side effects using this. Okay, so I have lambda, and then I have a range of 10. I'm passing it to map. Map takes a lambda and takes a range and applies the lambda to the range. Interesting. I would have positioned it the other way. Take the range and then the lambda. Weird. Okay, so map takes a lambda, takes a range, and for each element in that range, applies the lambda and then maps it. Okay, and then you have a list which I'm guessing converts it into a list. All right, or equivalently, you can do this. So this is brackets to indicate that this needs to go in a list, square brackets. And inside that you say, I want to do x to the power of 2 for x in range, which is more concise and readable. Not for me. I have to get used to it. I don't know. Is it concise and readable for you? What do you folks think of this thing? I've encountered this thing before, and like I've had some trouble. Right, let's do this. I'm going to create a separate file for this nonsense. What's this called? Comprehensions. Okay, comprehensions.py. I don't know why they call it comprehension. Is it because of how hard it is to comprehend? Okay, I'm going to copy this stuff here first to make sure that this works. And then I do a print of squares. And Python, do your thing. Okay, get a bunch of squares. Now, what do I need to do? Now I need to do this. Okay, so now what I'm going to do, don't need to print this here, or maybe just comment this. I'm going to say map of, so we're going to try and learn map. Okay, map takes a lambda and an array. I guess it's an array, or it can be a range, because a range basically returns I shouldn't say array, it returns a list, right? So let's say I take a lambda x colon x plus 1. I'm not going to do the exact same thing they did. I'm going to try out with something else. So I'm going to take lambda, which basically adds 1 to a number, and I'm going to pass a list. Let's say 2, 3, 4. And then I'm going to capture this in a list, and I'm going to print this thing. Now let's see what it does. So it's added 1 to it. So basically map takes lambda and a list and then applies the lambda to it. And then now I have list, which gets it into a list. Okay, built-in mutable sequence. Now what happens if I just print map? What does map return? What does this guy return? Map object. Okay, so it returns a map object. Interesting. So what if I do stir off this? What is a map object? No, doesn't do anything. I wonder what a map object is. So whatever it is, it's not a list. So I'm going to have to convert it into a list. So I do list off, and I basically have this converted list that I'm printing over here. So this is good. Now I can change this. It's more readable for Python developer such tasks. I'm guessing it's because I'm new to Python. Looks a little cryptic for me. So let's get used to this. All right, I'm going to comment this out as well. And now we're going to do the comprehension. Okay, so comprehension is, first of all, you have to have the bracket. And then I need to have the thing that I need to work on. So I need to do x plus 1 for x in. Is that how it works? Let me just take a look. I'm going off of memory. Yeah, for x in and then the iterable. Okay, for x in, can I do 2, 3, 4? And I'm going to print this. Actually not bad. I can see the appeal. Okay, I can see the appeal. All right, I'm going to do times 2 or power 2, and we're going to get the same thing. So basically what was happening over here, I can literally do that with this instead. You can do this. I can see the appeal now. This is not bad. This is not bad. I just have to get used to it. I think the problem that a typical Java developer will have when writing this kind of code is, I think we will normally tend to reach out for the thing that we are familiar with, right? So let's say I have an iterable, I have a list, and I want to square each element there. I'm probably going to reach out for a for loop because I don't know the collection API there. In Java, I would use a stream, but here it's like I have to remember to say, okay, so this is a use case for list comprehension, and I have to use list comprehension. That's not going to be obvious. So it's going to be like, you got to put it in your mind so that when that kind of a problem comes, you got to reach out for this tool. Maybe it just needs practice. Okay. This comprehension consists of brackets containing the expression followed by a for, and then 0 or more for or if clauses. 0 or more, really? For in range. Ooh, interesting. There can be more than one. Let's see. The result will be a new list resulting from evaluating the expression in the context of the for and if clauses which follow it. For example, this list combines the elements of two lists. They're not equal. Okay, x comma y for x in this, for y in this. Are they doing nested loops here? If x is not equal to y, is this a freaking nested loop? Man, looks like it. So this for is basically the outer loop, and this for is the inner loop, and you basically have x comma y as the two variables. Damn. Oh yeah, it's equivalent to, yeah, it's the nested loop. Okay, interesting. All right, so you can reduce this whole nested loop into one line, which can be a double-edged sword, can be a good or a bad thing. I wouldn't, like, if I hadn't known this, I wouldn't look at this and go, this is often square. Interesting. All right. Note how the order of the for and if statements is the same in both these snippets. For and if state, what? Note how the order of the for and if statements is the same in both these snippets. Oh, they're talking about this one and this one. Oh, yeah. I got that. If the expression is a tuple, example x comma y in the previous example, it must be parenthesized. Okay, you got to stick this thing here. Okay. Now I have some examples here. All right, let's take a look at this. So you have a list here. Create a new list with the values doubled. Okay, x times 2. Okay, we kind of saw it. X for, okay, the if is what does the filtering. Okay, got it. Apply a function to all the elements. Okay, if I don't have an if, that means that you have all of the values. If there is an if, then this is basically doing a filter. So filter and a map in one line. It's pretty cool. can assign variables in one line as well. It's called walrus operator. All right, let me take a look at that next. I think it's coming in the doc. I haven't encountered it yet. I've been looking at the doc from the beginning. We haven't encountered the walrus operator yet. Is it this thing? I remember walrus operator. Was it in some other language? It's this thing, right? Looks like the walrus. I think that's what it is. But yeah, we'll get there. We'll get there. Okay, call a method on each element. Weapon.strip. Okay, now how does this work? This works because what we need here is not a lambda. What we need here is a function object. Because a lambda is a function object, right? So this can be any function object. Let's actually test this out. I'm going to have, it's not going to be a lambda here. I'm going to say foo equals this. Oh no. I'm going to do def foo, which takes x as an argument, and then I return x to the power of 2. Okay, and now I should be able to use foo as the object here. This should work, right? Let's see. No, it didn't work. Why did it not work? This is a function, so it works only for methods, huh? Weapon.strip. Oh, I have to do the open close. Like this. Ah, okay. So I have to pass in as an argument, and so it's basically an expression. It's not a function. Okay, that makes sense. That's the reason why the parentheses exists here. It's not referring to the function object. It's basically an expression. So any expression you put there will work fine. It's not a lambda. Okay. It's just an expression. Cool. All right, create a list of 2 tuples like number square. Okay, I can create a tuple there, which is again an expression. Makes sense. It's just an expression. So a tuple is another expression. Okay. And I'm guessing a list would work as well, right? So I can create a list here. So let's actually try that out. I'm going to create a list of x and then x plus 1. For each element, I'm going to create a list. So I'm going to get a list of lists. Cool. Just an expression. Makes sense. All right, let's move on. So you can create a tuple, right? Tuple must be parenthesized, okay? Yeah, x comma x to the power of 2 doesn't make sense because it's 2 expressions, not a same one. So that's not gonna work. Makes sense. What is this? Right. Any expression will be evaluated. That's right. What are we doing here? It's a 2-dimensional array, and then we are doing num for element in vec for num in element. Okay, so here the expression happens to be a list comprehension expression, right? So this is the first list comprehension expression that runs for num in element. Something needs to happen. What is that something? It is this list comprehension. So basically it is going to get each number in, wait, what's happening here? Num for element in vec for num in element. Oh, it's the other way around. So this happens first and then this happens. Right? Num for element in vec. So you're going to get num, which is going to be the array. All right, I'm confused now. Confused for this one. Let's try this out. Okay, comment this out as well. So let's see what happened here. So first they have a two-dimensional array, two-dimensional list, I should say. And now, and they have this. So this seems to become, I'm trying to see what I can remove. Okay, so num for element in vec seems to be a complete expression, right? Because for num in element doesn't make sense because element doesn't exist until this is there. So if I were to remove this, num for element, oh, that doesn't even make sense. Num for element in vec. No, I don't get it. I don't get it. Flatten a list using a list comp with two for. You're flattening a list, which means that I'm trying to understand what happens first here, right? There are two fars, which means, so the for here is basically triggering a for loop, right? So when you say for x in range, it's basically doing a for loop. And for each element in that for, it's passing it to the expression. Oh, so it's going from right to left. So is it doing this? So for num in element, for element in vec, do the number. Ah, now it makes sense. That's the nested loop, right? So for num in element and for element in vec, do the num. So it's basically flattening it out by picking each element. So the first for loop gets the array and the second for loop just prints it. So it's flattening it out. Makes sense. I don't know if it made sense for you, but it made sense for me. It's flattening. It's basically a nested for loop. List comprehensions can contain complex expressions and nested functions. From math, import pi. And what are we doing here? str round of pi comma I for I in range of, yeah, this is nothing new. We found out that this part is an expression. So you can stick whatever expression in there and it's going to work fine. Okay, got it. Nested list comprehensions. The initial expression in a list comprehension can be any arbitrary expression, including another list comprehension. The initial expression can be named. Yeah. Oh, that means because it's nested. Okay, so here I'm going to go 3x4 matrix, implemented as a list of 3 lists of length 4. Okay, the following list comprehension will transpose the rows and columns. So what is this doing? So it has an expression for I in range of 4. Okay, so it's going to go 0, 1, 2, 3. And then what is it doing for each of those? For each of those, it's looking at the row in the matrix and then doing row of I. So it is going to go 0 and then 0 and then 0. That's going to be the first pass because that's a 0 in this range. Okay, row of I for each row. So it's going to be the first row is 0, second row is 0, and the third row is 0. And then it's going to go to the next in the range, which is 1. Again, it's going to do the first row is 1, second row is 1, and the third row is 1. That's what this is doing. Transposing rows and columns. Neat. I like it. As we saw in the previous section, the inner list comprehension is evaluated in the context of the for that follows it. So this example is equivalent to for I in range transposed dart append. Okay, that makes sense. Which in turn is the same as for I in range transpose row. For row, again, another loop. Okay. In the real world, you should prefer built-in functions to complex flow statements. The zip function would do an ideal job for this use case. So there is a zip function, zip of star matrix. The unpacking. So it's unpacking it. So basically you have a bunch of individual array arguments. We just saw unpacking earlier, right? So basically when you do a star matrix and matrix happens to be a two-dimensional list, what you're going to get is a single comma separated individual list. So you have this comma, you almost think of it as remove the square brackets, right? So, or the outer square brackets. Then it's going to do a zip of everything. And I'm guessing zip is basically taking the corresponding values for each list. You pass it a bunch of lists, it's going to take all the 0th, all the 1th, all the 2nd, and so on. Iterate over several iterables in parallel, producing tuples with an item from each one. Yeah, makes sense. Makes sense. And then you're going to convert it back to a list. The del statement. There is a way to remove an item from a list given its index instead of its value. The del statement, it differs from the pop method, which returns a value. Okay, so del removes the element, pop returns the value. What's the big deal? What's the difference? If you ignore pop, is it exactly the same as del? The del statement can also be used to remove slices from a list or clear the entire list, which we did earlier. That's what the difference is. So you can clear this out. You can say remove a of 0, or you can say remove a of 2 to 4, or you can say remove everything. That's what del does. You can give it a range. Del can also be used to delete entire variables. Del A deletes entire variables. What happens to the variable? Does Python do garbage collection? It better do garbage collection because there are going to be references, right? I'm guessing it does. Anybody think Python doesn't do garbage collection? Referencing the name A hereafter is an error, at least until another value is assigned to it. We will find other uses for del later. I know there was a section earlier which was talking about symbol tables and how, if a variable is in the scope, it's basically an entry in the symbol table. So I'm guessing del A removes A from the symbol table of whichever scope it is in, which makes sense. Tuples and sequences. Tuples, and sequences. We saw that lists and strings have many common properties, such as indexing and slicing operations. They are two examples of sequence data types. See sequence types, list, tuple, range. Okay, it's kind of like they have common operations. Okay, that makes sense. List, tuple, and range. They all have like a bunch of values. There's no mention of arrays so far, so I'm guessing you just treat them as lists. You don't say arrays in Python. Like if it's a bunch of stuff, then it's a list. If it's a fixed number, then it's a tuple. And I still have no idea what a sequence is. We'll find out. Sorry, range. Okay, sequence is basically the type. You have list, tuple, and range. Okay, that makes sense. Range is a function which emits values. You don't store the values internally because you don't want it to consume so much space. To say range of 0, 100, it's kind of like a function object which gives you the value rather than store 100 elements. The others do store those elements. Makes sense. Since Python is an evolving language, other sequence data types may be added. There's also another standard sequence data type, the tuple. Okay. From array, import array. So there is array. What's the difference between an array and a list? Oh, it's like a dedicated data type, huh? So they have like a data structure that you have to import. List is more built-in. I don't want to call it a primitive, but I get the idea. Arrays in Java are kind of built-in, and you want to use a list, you're gonna import it. But here in Python is the opposite. List is what's the built-in stuff. You want to use an array, you import it. Yeah. Um, a tuple consists of a number of values separated by commas. For example, this. Okay. And then I can access by using the position location. Okay. And if I just print the tuple, I get in parentheses. Oh, that's what this was, right? We did something like this earlier when we did lambdas, right? When we printed this and we had annotations, it returned a tuple. Array consists the same item types. Ah, okay, okay, that makes sense. With the list, I can basically stick in anything that doesn't have type safety. Interesting. Thank you for clarifying that. All right, so I'm going to create sequence.py. Okay, so I create a tuple by basically just having comma separated values. Tup equals 1 comma 2 comma 3, and then I print tuple Python sequence. So it prints with this parentheses. I don't have to specify the parentheses here, but if I have to access a value, I use square brackets like this. So I get that individual element. I'm guessing it has the same out of bounds thing. Can it do ranges? I'm guessing it can do that too. 0:2. What happens now? Yeah, so that seems to work fine. The same range syntax works. Okay. List can have different types of elements. You can make something like this in a list. Right, right. So you can create multiple, like a list. It's not type safe, but an array, I'm assuming, it enforces type safety, which is handy. Okay. So lists in Python are like arrays out of the box in JavaScript, like zero type safety. Cool. Okay. Tuples may be nested. Okay, so I can say tup is this, and then I can say tup2 equals tup of 0:1, comma tup of 0:2, comma 10. It's not this, it is square. And then square. And then I'm going to print of tup2. Okay. Why is it 1, comma? Oh, because it's just one element. Interesting. If a tuple has only one value, it has this interesting, like it shows the parentheses, it puts a comma and it doesn't put the second element, which is so weird. I don't know why they did that. Maybe to indicate that it is a tuple, but just a parentheses would have done. It's an odd choice. But oh well. Would it be possible to please have this meeting over Google Meet or something along with YouTube streams? It can be a bit more interactive. Let me see if I can change the latency on the stream. Also, is there a schedule? There isn't a schedule, but I'm planning to do this a little more often. You can catch the replays, my friend. It's not. It entirely depends on my availability, so I really cannot promise a schedule. Let me think about it. Let me try and have a schedule. If you're really interested, you want to show up, we can try to have a schedule. I'm going to try and reduce the latency. I don't want to switch to a Google Meet or anything like that now. I'll try and reduce the latency if possible. Edit. They have a low latency option here. Latency, where is it? Stream settings. Oh damn it, I cannot change it now. I cannot change it now. My apologies. Um, it's yeah. Unfortunately, I cannot change it. But please bear with me for this one. For the next one, I will try and add. I'll try and add one more. Um, yeah, yeah. Help in the chat is very useful. So yeah, definitely, definitely appreciate that. There should be less latency for sure. Because if there's comma, it'll be interpreted as generator object. If there's no comma, it'll be interpreted as generator object. Oh, just the parentheses is interpreted as generator. Okay, I have no idea what generator is. So um, I guess I will know once we get there. Okay, for a equals I for I in sequence, this is a generator function. Okay. So if it is square bracket, then it is list comprehension. But if it is parentheses, it's a generator function. Interesting, interesting. Because uh, the syntax looks very similar to the list comprehension, right? You replace this parentheses with square brackets, and you got list comprehension. Interesting. All right. I guess we'll get there when we get there. All right. Moving on. As you see on output, tuples are always enclosed in parentheses so that nested tuples are interpreted correctly. They may be in input. They may be input with or without surrounding parentheses, although often parentheses are necessary anyway. The tuple is a part of a larger expression. Okay, that makes sense. It's not possible to assign to the individual items of a tuple. However, it is possible to create tuples which contain mutable objects, such as lists. Okay. Okay, I'm going to have to read that again. It's not possible to assign individual items of a tuple. However, it's possible to create tuples which contain mutable objects such as lists. Okay, so I cannot change the tuple is what it's saying. So I can't go here and say tup of 0 equals 10. This is not possible, right? Is this what it means? If I run this, yeah, tuple doesn't support item assignment. Okay, but I can do pretty much all the other stuff that that a tuple can do. Okay. So this is a tuple within parentheses 1, 2, 3, and then this is a tuple with one element. Yes. So when there is only one element, it puts a comma there to separate it from, like you said, a generator function, which makes sense. Awesome. Thank you for that. Let's move on. Although tuples may seem similar to lists, they're often used in different situations and for different purposes. Tuples are immutable and usually contain a heterogeneous sequence of elements that are accessed via unpacking, see later in the section, or indexing, or even by attribute in the case of named tuples. Yeah, tuple looks like it's immutable and list is mutable. Yes, that's right. That's right. The read-only operations are the same, but you cannot do write operations on a tuple. It's going to give an error. Okay. Unpacking. I wonder if this unpacking is the same as the other unpacking that we encountered with the star. That's kind of it, right? We did encounter unpacking for a list. I wonder if it's the same. Later in the section, we already covered it. Or indexing, or even by attribute in the case of named tuples. There is named tuples. Interesting, kind of like named arguments in a function. Lists are mutable, and their elements are usually homogeneous and are accessed by iterating over a list. This is a lie. Oh, they say usually. Okay, they don't have to be homogeneous for lists. They can be anything, but they're usually homogeneous. Got it. A special problem is the construction of tuples containing 0 or 1 items. The syntax has some extra quirks to accommodate these. Empty tuples are constructed by an empty pair of parentheses A tuple with one item is constructed by following the value with a comma. This is exactly what we just discovered. Okay, empty a tuple with one item is value followed by comma. It's not sufficient to enclose a single value in parentheses. Ugly but effective. Effective? Why? You shouldn't have had other syntax using that same format, Python. That's the problem. That's why this needs to be ugly. Okay, for example, this is empty, singleton, okay, hello, comma. Okay, when it's a single element, it doesn't need parentheses. Well, you didn't need parentheses anyway. Just put a comma at the end. Okay. Length of empty is 0. Length of singleton is 1. Singleton is, it sticks that comma, parentheses at the end. Okay. The statement t equals value 1, comma, value 2, comma, value 3 is an example of tuple packing. The values 1, 2, 3, 4, 5, second and third are packed together into a tuple. The reverse operation is also possible. I can unpack a tuple this way, sequence unpacking. Okay, so I can do, now I have tup 2, which has like how many elements? I have 1, 2, 3 elements. So I can say x, comma, y, comma, z or z equals tup 2. I can unpack it. And so I can print x, comma, y, comma. All right, let's see. Okay, so it's going to get the individual elements. This is interesting because now we have seen this on the left-hand side and the right-hand side. I wonder, any of you Python experts here, let me know. I wonder if when you do this thing, right, when you do, like I have x, comma, y, right? So let's say I do x, comma, y equals y, comma, x, right? This is possible in Python. You're basically swapping the values. I wonder if it's the same mechanism that's happening here. I wonder if this is basically swapping, basically creating a tuple and unpacking it on the other side. Is that what's happening here? Seems like it, right? This is a tuple. See, this is a tuple. This is a tuple. And this is unpack of a tuple, like we saw here. So is this what's happening? Let me know in the comments, guys and girls. I feel like that's what this is. So let me know. But that makes sense. You can have if you put the commas on the right hand side, it becomes a tuple. And if it's on the left-hand side, you have unpack. Got it. All right. This is called, appropriately enough, sequence unpacking, and works for any sequence on the right-hand side. Sequence unpacking requires that there are as many variables on the left side of the equal sign as there are elements in the sequence. Note that multiple assignment is really... This is what I just did. I'm faster than you, Python duck. Multiple assignment is really a combination of tuple unpacking and sequence unpacking. This is literally what I was wondering. All right, that makes sense. I promise I haven't read this before. Okay, this is literally my first time. It was just the thought that came to mind because I remember doing that before. And this is very similar to destructuring in JavaScript. Okay, in JavaScript, you need to put it in like an array to do the destructuring. Here, it's using the tuple syntax to do destructuring. Here it's called unpacking, but it's kind of like the same concept. It uses a tuple as the backing, as confirmed by this line. All right, let's move on. Set. Oh, I have a comment here. Hi, Kaushik. Hello. Thank you for joining. Python also includes... Very satisfying with the intuition matches. Maybe this is why they call Python as a good language, because these things have to be intuitive. The more intuitive they are, the lesser the pain for the developer. I'm not saying Java isn't like that. Java is pretty intuitive as well, especially with types. Sets. Python also includes a data type for sets. A set is an unordered collection with no duplicate elements. Okay. Basic uses include membership testing and eliminating duplicate entries, kind of like set in Java collections. Set objects also support mathematical operations like union, intersection, difference, and symmetric difference, again, like Java collections. Curly braces on the set function can be used to create sets. Note, to create an empty set, you have to use set parentheses, not curly brace. The latter creates an empty dictionary, and the data structure we'll discuss in the next section. Okay, in order to create a set, you have to use curly braces, except when you have to create an empty set. When you create an empty set, don't use empty curly braces. That becomes a dictionary. We just talked about intuition. This is not intuitive. Python, what are you doing? This is not cool. You're asking the developer to remember and distinguish between these things. This is bad syntax, Python. All right, but we got to remember it. Anyway, so we have a set. This is a set in curly braces. Basket is of type set. And I print basket. It is going to... okay, I have a couple of comments here. Let's get to this real quick. The comma in a singleton tuple is probably to accommodate the syntax where we can create a tuple without any round brackets, like the parentheses, right? Example, x equals 1 comma. Okay. Not because 1 is a generator, because if we do x equals 1 parentheses, not a generator, but simply an int. Okay, it becomes an expression at that point. Is that what it is? Yeah. Yeah, I guess it's yeah, that makes sense, because I was wondering, like, why would it print it? It makes sense that it is. There's no reason why somebody would put a parenthesis on a single value. So you could potentially, so if I were to print a single value tuple, right? I'm printing the tuple. It could pretty much print like this, and I wouldn't go, oh, I don't know if this is a tuple or an expression which contains the value 1. I would know it's a tuple, but they're doing this to distinguish this from this, which I don't know is necessary. But I get what you mean, though. It's doesn't matter. This is the syntax that they've used. It's okay. It's all good. It's all good. Where was I? Okay. Print of a set, prints in curly braces, okay? Orange in basket, fast membership testing. Oh, they have custom syntax for it. It's not a method on a set object. You say orange in basket. So it's the same in syntax that we've seen for iterables. Is set an iterable? I'm guessing it is. Should be. Makes sense that it's iterable. In that case, this syntax is basically the iterable syntax that we've seen so far. Okay, demonstrate set operations in unique letters from 2 words. So I have a set of these letters, I have a set of these letters, and then I get all the unique letters, and then I can do subtraction. Oh, I can do subtraction this way. It's not a method. They have custom syntax for this. I do minus to R, and this one, what is this? This is an letters in A or B, but not in both. So it's kind of like the opposite of intersection. What's it called? Symmetric difference. That's what it's called. Interesting that they have this as the syntax, because with Java, all these are performed on objects. So you kind of know what you're doing. Like, it's a method on a set. But here they're reusing arithmetic operators and all these other operators to perform on set. Again, I don't know if it's a concept of, like, with Java, these collections are separate frameworks. Like, it's almost like a thing that got added into the language later. But this one is kind of like a little more integrated into the language, I guess. So maybe they can do this while Java couldn't have done it, right? Imagine doing object1 minus object2 in Java. That wouldn't work. So I guess, okay. Similar to list comprehensions, set comprehensions are also supported. Again, I'm assuming it's because comprehensions work for iterables. Hey, hang on, does comprehension work for tuples? Can I do x times 2 for x in tup2? Does this work? It works. What is it doing? What is the I don't know. It took to two-dimensional. Hang on a second. Let's print the original value and then print the comprehension as well. Okay, so the original value is this. And then what has it done? Oh, times 2 for a tuple basically duplicates the value. Interesting. You see this? I had a tuple of one element. I've done a times 2 for the tuple. I didn't mean to do that. Okay, I just wanted to see if the comprehension works for a tuple. But guess what happened? I did a times 2 for a tuple. It just created one more element. It's super interesting. See this? 1 comma 2 was a tuple. 1 comma 2 times 2 is basically 1 2 1 2. Okay, when it was a number, then it did a times 2 like you would expect. Isn't that crazy? Okay, so basically, I don't know why they keep bringing this up. So comprehension is not list comprehension. It is iterable comprehension. It works for tuple, it works for list, and it now seemingly works for set as well. Okay. How are you? I am doing much better now. Thank you for asking. I have been away for a while for health issues, but I'm doing much better now. Okay. Dictionaries. We just complete dictionaries and then we'll wrap up. It looks like I've been streaming for a couple of hours already, right? So just do this and we'll wrap up. Dictionaries. Another useful data type built into Python is a dictionary. See mapping types dict. Dictionaries are sometimes found in other languages as associative memories or associative arrays. What? Which language calls a dictionary as associative memories? I want to know that language. Anybody in the chat, let me know. That's crazy. It's a map or a dictionary. Unlike sequences, which are indexed by a range of numbers, dictionaries are indexed by keys, which can be any immutable type. Strings and numbers can always be types. Tuples can be used as keys if they contain only string numbers or tuples. So the object essentially has to be immutable. The type has to be immutable. That's interesting. It's interesting. Okay. If a tuple contains any mutable object, either directly or indirectly, it cannot be used as a key. You can't use lists as keys since lists can be modified in place using index assignments, slice assignments, or methods like append. Yeah, lists are mutable. We get it. So you cannot use it as a key. It's best to think of a dictionary as a set of key value pairs with the requirement that the keys are unique within one dictionary, essentially a map. Okay, makes sense. A pair of braces creates an empty dictionary. And this is the reason why we couldn't create an empty set while we could create a set using this. They've used the same syntax, right? For a set, you put a curly brace and put the elements inside. But for a dictionary, you again put a curly. But if you don't have any element inside, you don't know if it's a set or a dictionary. By default, it becomes a dictionary. For an empty set, you got to use this thing, set method call. Okay. Okay. Placing comma-separated list of key value pairs within the braces adds initial key value pairs to a dictionary. This is also the way dictionaries are written on output. Okay. The main operations on a dictionary are storing a value with some key and extracting the value given the key. It's also possible to delete key value pairs with del. Del again. We can use del to delete key value pairs. I'm guessing you did del key or something like that, or del dictionary of key. Okay. If you store using a key that is already in use, the old value associated with the key is forgotten. If it's an error to extract a value using a non-existent key. Okay. It's an error. It's not going to say none. Okay. It's not going to give a empty value. It's an error to extract something which doesn't from a key which doesn't exist. Interesting choice. Okay. Performing list of D on a dictionary returns a list of all the keys used in the dictionary in insertion order. If you want it sorted, just use sorted of D. Oh, it returns it in insertion order. Interesting. dictionary keys in insertion order, which means that they're probably not using hash map. They might be using some kind of a sorted map implementation. They remember the insertion order, which is interesting. I wonder what they need it for, just for a list? Or is there another way you can leverage the insertion order? If you want it sorted, use sorted of D. To check whether a single key is in a dictionary, use the in keyword. Okay. Again, iterator. Here is a small example using a dictionary. All right, I have a dictionary of string str, so it's immutable. They can be a key. The value are numbers. Tell of Guido is this. And then if you look at the dictionary, it has an additional key with this new added value. Tell of Jack, you look it up. Del, a certain value, the dictionary of a thing, and then it'll go away. And then if you assign something else, and now I do print, sape has gone away, and Irv is here. List of tell is going to give all the keys. Sorted of tell is going to give, wait. Sorted of tell is going to give the keys in sorted order. I thought sorted of list of tell. I can just do sorted? That's interesting. Let's try that out. Oh, yeah. That's what it says. Sorted of D. It's interesting that it just assumes that you want a list of keys. I'm sorting a dictionary, and what I'm going to get back is a sorted list of keys. That doesn't sound too obvious. This is an odd choice. I don't know why it's doing this. I would have assumed it would be sorted off list of tell, which makes sense because list of tell is what's giving the keys, right? I don't know why Python decided to do that. All right, Guido in tell. Yeah, this is basically iterable, looking at an iterable, not in. Okay, makes sense. A dict constructor builds dictionaries directly from sequences of key value pairs. Dict of. Okay, the constructor of dict builds dictionaries directly from sequences of key value pairs. I see. So I can give it a list where each element is a tuple. And it's going to construct a dict. Okay. In addition, dict comprehensions can be used to create dictionaries from arbitrary key and value expressions. So I can say x colon x to the power of 2 for x in 2, 4, 6. So what is it doing? I'm creating a dictionary. I'm creating x colon this. Okay. So I'm using wait, hang on. What is happening here? This is not dict comprehension. This is tuple comprehension, but the result is a dict, right? Is that what they call dict comprehension? Because if you just look at this, right, this is what starts it off. And this is tuple comprehension, right? You're basically doing a for each element in the tuple. And then what you get from that, you're making a dict out of it. You're saying x colon x to the power of 2. So you put it in curly. So they call it dict comprehension. Interesting. When the keys are simple strings, it's sometimes easier to specify pairs using keyword arguments. So you have dict of key equals value, key equals value. Okay. It's almost like you're passing named arguments, but this is basically key equals value. I'm guessing they're doing star when they're accepting this in dict, right? This is probably star, and that's what's going to give you a dict anyway, right? I'm guessing that's what the constructor of dict is doing. Interesting. Okay. Well, let's see. Java supports maps with mutable objects as keys. What do you think of the consequences of this? Is Java more unsafe due to the fact, or is Python too rigid to not allow it? I feel like it's probably a good idea to not allow it because it's not just map, right? It's also about anything that requires a hash. You put things in a hash set, right? The thing goes into, you create a hash out of it, and you assume that the hash is going to stay the same. You're not going to change it, but that could potentially change, right? The thing that you're hashing could potentially change, and the hash code is going to be very different. So at some point of time, the hash set is going to rehash and it's going to be fine. But until then, you end up in a bad situation. So I guess I would say yes, Java is a little unsafe in that regard because it kind of expects the developer to maintain that discipline. But I also feel like, for the most part, when we're working with data, I haven't encountered a situation where I had to change an object in a hash set like that. It's like we usually deal with dumb data carriers, right? I'm getting employee objects, and I'm going to basically have uh, an employee object which is going to just remain the same, pulling it from a database, and it's going to just remain the same. And now I can put this as a key, I can put it in a hash set, and Java is not going to complain because I could potentially change it. It's like, hey, Java, trust me, I'm not going to do it. Java is going to listen. But with Python, I don't even have that option. So I would say, I don't know, I would say it's okay to leave it. And if the developer shoots themselves in the foot, it's on them. That's my position. I would rather have it as an option and take care rather than just say not have it be an option at all. I think once I start coding in Python, I will realize the implications of this limitation. I can only use primitives or tuples, cannot use any object. Seems odd, seems limiting in my opinion. So that's what I'm thinking. I could be wrong. Maybe once I start writing Python code, I'll go, well, not a big deal. But at this point, I would rather have the option. That makes sense. All right. Okay. So with this, I'm gonna stop over here. Or actually, let's power through this. We'll finish this part and then we'll take a break. Okay. And we'll wrap up this thing, and maybe I will stream tomorrow. Looping techniques. When looping through dictionaries, the key and the corresponding value can be retrieved at the same time using the items method. Okay, so I have a dictionary, and I'm going to say key, comma, value in knights.items, print k, comma, v. Okay, so I have another comment. Thank you, Kaushik. I created a nested loop today at work. Thanks to your stream, I'm going to change it to comprehension. The next stream is similar time. I'll be glad to learn more. It's this is a case of the blind leading the blind. I would say I would actually rephrase that. I'm probably a much more ignorant about Python than you, Yash. So if I have helped by the very fact that I'm learning Python, it's great. I wouldn't assign a lot of value into um, my teaching part of things. It's more of like shared learning, which is what you're implying. So I'm just going to keep quiet now. Thank you for calling that out. All right. Yeah, thank you. I just turned it back on. Thanks for letting me know. I'd forgotten that it switched. All right. Looping techniques. When looping through dictionaries, the key and corresponding value can be retrieved at the same time using items method. So I can get the dictionary and I can say key comma value in knight.items. I'm guessing it's because each value in knight.items is a tuple. Let's find out. Let's find out. If it's a tuple, then basically we're doing destructuring, or what's it called? Unpacking, right? That's what it's doing. They have to tell what the fundamental concept is here, right? This, like, if they tell us that what knight.items returns a tuple and what you're doing here is unpacking, it makes a lot of sense. You can connect those concepts. They're talking as if it's special syntax. It's like unnecessary load on the reader's mind, right? Provided that's what it is. Let's find out, right? I had to connect the dots when I was reading this. Well, we'll see. So I have I'm going to create a dictionary here. We go to data structures, right? I'm going to create a dictionary. I'm just going to copy paste this thing. Okay, and now I'm going to do a for in nights.items, this one. Okay, then I'm gonna print. Now this is going to print, this is going to print the key and the value. Okay, now if I were to take just the value, I'm guessing this is going to be a tuple, and I print this, I'm guessing it's returning a tuple, and that's the reason why it's working. Let's verify that. Yeah, that was it. It was basically doing a tuple. Night.items returns a tuple, and what we're doing here is unpacking. Well, thanks, tutorial. Okay, when looping through a sequence, the position, I don't think it's a tuple. You can do type of night.items to see the type. Oh, okay, twist in the tail. Thank you for letting me know. Let's find out. Let's find out. My argument still stands, though. They should have mentioned what the type is so that I don't get into the false conclusion that I did that it was a tuple. All right, let's see. I'm going to say, what is this? Okay, and I'm going to do print type of, what is this? Oh, it is a tuple. It is a tuple. So yeah, it says class tuple. So I don't know if it's really a tuple or it's something else. Is it class what it says? Like it's supposed to say class for these things. I'm guessing because tuple is an object. So I don't know, work tag. Correct me if I'm wrong there. It seems to be, yeah. It's maybe saying that it's an instance of a class that's a tuple. Is that what's going on here? I don't know. Anyway, all right. When looping through a sequence, the position index and the corresponding value. Oh, by the way, I want to say thank you for type. I didn't know that. I can say type and find out what the type is. I learned something new. When looping through a sequence, the position index and the corresponding value can be retrieved at the same time using enumerate. What does enumerate do? Enumerate of tick, comma, tack, comma, toe. Oh, it's going to get the position and the value. Okay, I get it. I wonder if this is a tuple as well. So let's find out. So I'm going to say, get over here, for tup in enumerate of a list 1, 2, 3. Oh, no, I'm going to change it to string because the position is going to be coming up as well. And I'm going to print tup. We have a Python expert in the house, folks. Hi, Naveen. How are you doing? I hope I provide enough entertainment for you by flailing and messing around with Python. Thank you for joining my stream. All right. I'm gonna ask you questions. All right. You're the Python expert in the house now, so you're gonna answer questions. Thank you. Okay, so I'm guessing this is a tuple as well. So let's find out. Looks like a tuple. Well, let's find out the type of what is getting printed. It seems to be a tuple as well. So it makes sense. So all these things are returning tuples, and we are able to use the destructuring to capture those values. In the case of items, the destructuring is going to be key value pairs, and in the case of enumerate, it's going to be the position and the value itself. No more expert now. Yeah, right. This is like the third hour of my Python, my friend. So it's, yeah, I have a long way to go. I have a long, long way to go. Anyway, so so that's what's happening. Items is a tuple of um, items is a tuple of key value pairs. Enumerate is a tuple of takes a list and then creates individual tuples of position and the value, which is why the destructuring works, which makes sense. To loop over two or more sequences at the same time, the entries can be paired with a zip function. Okay, zip takes two lists and then it creates tuples. Okay, it's almost like you're creating. Okay, that makes sense. That makes sense. So does zip return a? So zip returns an array, a list of tuples, right? Which is why I'm able to do for in on that array, and each one is going to be a tuple, right? Just like this other thing. Okay, so let's find out. Let's find out. I'm going to just copy paste this thing here, and let's see if it is indeed an array of tuples. So I have questions and answers. So now if I do zip of questions, comma, answers, I'm going to get back a list of tuples, right? It's going to be name and Lancelot, these list of tuples. So let's do print of zip. Oh no, it's not. It's a zip object. Interesting. I'm guessing that works because it's an iterable, and that's the reason why this works. It's not a list, but it's a tuple. It's an iterable, which is why I'm able to get I'm able to do a for. Let's take a look at this. For val in, and I can do print of val. And now I'm going to get those tuples, right? And what is the type of this thing? Let's verify this before I call it a tuple. Yeah, this seems to be a tuple too. Okay, makes sense. It's not a list, but it's some iterable. Type is useful when you struggle to parse API JSON response list dict problems. Okay, interesting. In JavaScript, I'm used to doing JSON.stringify, so I guess type is going to help instead of that. We should do a session like this together exploring Rust. Oh, yeah, Rust seems to be the new cool thing that all the cool kids are learning. So sure, Naveen, we should do that. We should definitely do that. We can try it out together. Okay. Moving on. To loop over a sequence in reverse, first specify a sequence in a forward direction and then call reversed. Okay, makes sense. Reversed. A zip can zip together any number of lists, two or more. Okay. So if it's more than each one of, it's basically going to be a vertical slice of those lists, right? So if there are three lists, each tuple is going to have three elements, right? So yeah, that makes sense. Okay, reversed reverses a list. Here they've demonstrated it with range, but I get the idea. To loop over a sequence in sorted order, use sorted function, which returns a new sorted list while leaving the source unaltered. Oh, sorted returns a new one. I'm guessing reverse. Does reverse return a new one? Yeah, I'm guessing it does. Just verify that once. Just quickly verify this, all right? So I have a print of questions. I'm going to say reversed of questions. So based on the design principle that they mentioned, right? If this thing returns something, that means that it didn't change the original list. because if it's doing something in place, it doesn't return anything. So look here, it's actually returned the reverse iterator object. So it's returned a new iterator, and the original one has remained intact. So they're following that principle that they've mentioned outright. It can be handy, right? You know whether you can know whether something is modified in place or not by just examining the return type, which is pretty cool. Okay, using set on a sequence eliminates duplicate elements, kind of like what happens in Java using the set constructor. Use of sorted in combination with set allows a sequence over a sequence is an idiomatic way to loop over unique elements of a sequence in a sorted order. Okay, here's the thing that I know from talking to folks who know Python, right? When people say idiomatic way, that means you better do it that way, right? There is apparently a Python way of doing something, which is the idiomatic way. The others is the idiotic way, which you don't do, right? Always prefer the idiomatic way. And when they say this is how you're supposed to do it, right? Kind of best practices. It's like always add a period or a full stop at the end of a doc string, as we've seen earlier. I'm never gonna let that go. I'm gonna I'm gonna keep teasing the people who wrote that thing forever. Okay, sorted, set, basket. Okay, makes sense. It is sometimes tempting to change a list while you're looping over it. However, it's often simpler and safer to create a new list instead. Okay, yeah, it makes sense. You don't want to do loop over a list that's changing. I don't know if they have fail fast iterators here. Don't know what happens when they do this, but it makes sense to have a new list every time you're changing something. Right, so you have raw data, there's a bunch of values. Filtered data is empty. For value in raw data, if not math dot is nan of value, filter data dot append of value. Okay. Or you just use list comprehension. Why are they doing this? I'm going to try list comprehension here. I want to see how this works. They keep advertising about list comprehension. We got to do this, right? Okay, I have raw data, filtered data. What do they want? They want to filter by math dot is nan of value, right? Should be able to do this. Filter data is n in raw data if this is what you do, right? Isn't this how it's done? Square bracket was not closed. What? Oh, for n in raw data where n. Isn't this how it works? I'm going to be really happy if I do this. This is the first time I've done the list comprehension on my own. I'm going to be super proud of myself if this works. Yes, I did it. Feels good. Feels good. I'm now a convert. I used to hate this thing, but it feels so good to do this now. So I'm going to petition for Java and JavaScript to have list comprehension. If not, oh yeah, there is a not here. You're right. You are right. It is if not. Okay, I'm just going to do it for the sake of completion, and I can still feel good about myself. Not. Yes. Okay. Cool. I can see what's the big deal about list comprehension now. I have changed my mind. All right. The idiomatic way is to make Python incomprehensible and to shrink 8-line Java code into a single line of Python. Well, it's I don't know, man. It's just the way, I think a lot of software development is based out of a lot of superstition, right? It's all superstition, right? Don't go when a black cat crosses the road. Well, I don't know. Other people are doing it, so I do it, right? It's kind of like that. I'm sure some of them have valid reasons for this stuff, but then they go, well, this is I'm opinionated. This is the way we do things, and then everybody follow it. And if you don't follow it, you're an idiot. Um, yeah, so maybe there's something there, but I see what you mean. I totally see what you mean. All right, more on conditions. The conditions used in while and if statements can contain any operators, not just comparisons. Huh. The comparison operators in and not in are membership tests that determine whether a value is in or not in a container. The operators is and is not compare whether two objects are really the same object. All comparison operators have the same priority, which is lower than that of all numerical operators. What are they talking about here? I don't get it. Comparisons can be changed. For example, a less than b is equal to c. Test whether a is less than b, and moreover, b equals c. Okay, another shortcut. I'm going to bring this comment over here. Okay, so a less than b double equals c is basically the same as a less than b, and I'm guessing it's an and. I would say moreover. I'm guessing it's an and b equals c. Interesting. Arjit, this is idiomatic Python. All right. Comparisons may be combined using Boolean operators and an OR, and the outcome of a comparison or of any other Boolean expressions may be negated with not. These have lower priorities than comparison operations between them. Not has the highest priority and R has the lowest. So that A and not B or C is equal to A and not B or C. Okay, that's literally how I read it. So that makes perfect sense. As always, parentheses can be used to express a desired composition. Okay. That makes sense. The Boolean operators and an OR are so-called short circuit operators. Their arguments are evaluated from left to right, and evaluation stops as soon as the outcome is determined. Again, same as Java, makes sense. For example, if A and C are true, but B is false, A and B and C does not evaluate expression C, just as I expected. When used as general value and not as a Boolean, the return value of a short circuit operator is last evaluated argument. It is possible to assign the result of a comparison or other Boolean expression to a variable. Okay, so I have string 1, string 2, string 3 equals 3 strings. String 1 or string 2 or string 3, you're going to get the first non-empty string. Oh, this is like JavaScript. JavaScript works exactly the same way. You can say value or value and assign it to a left-hand side, and it is going to, the first value is null, the value that gets assigned is the second value. So this is very much like JavaScript. Note that in Python, unlike C, assignments inside expressions must be done explicitly with the walrus operator. All right, here it is, the walrus operator that you were mentioning, Nikolai. This avoids a common class of problems encountered in C programs, typing equals in an expression when double equals was intended. All right, let's look at the walrus operator. They haven't given an example here, so let's find out. Why can't I use assignment in an expression? Oh, while. Okay. Cool. That makes sense. So when you want an assignment to also be an expression, then you use a walrus operator. Interesting. Again, it's one of those Python things that I have to remember to do because my default JavaScript and Java instinct is going to go like split it into two separate expressions. So I have to remember that the walrus operator exists. All right, I think we're about at the end. Let's wrap this up with this section, comparing sequences with other types. Sequence objects typically may be compared to other objects with the same sequence type. The comparison uses lexicographical ordering. First, the first two items are compared, and if they differ, this determines the outcome of the comparison. If they're equal, the next two items are compared, and so on. Interesting. So they should compare in order until either sequence is exhausted. If two items to be compared are themselves sequences of the same type, the lexicographic comparison is carried out recursively. If all items of the two sequences compare equal, sequences are considered equal. If one sequence is an initial subsequence of the other, the shorter sequence is the smaller, lesser one. Lexicographic ordering for strings uses Unicode code point number to order individual characters. Some examples of comparison between sequences. Okay, here are two sequences 1, 2, 3, 1, 2, 4. It checks 1 equal, 2 equal, 3 is not equal to 4, 3 is less than 4. So the sequence is less than the sequence. Understood? 1, 2, 3, 1, 2, 4. Again, same thing happens for a list. This one's a tuple, this one's a list. With string, it is character by character comparison. The first thing detects what the difference is if the first letter matches the second character, determines what the difference is. 1, 2, 3, 4, 1, 2, 4. Again, this is lesser because 3 is less than 4. Okay. 1, 2, 1, 2 minus 1. This is lesser because it has lesser number of elements. Okay. Because it's not like there is a 0 over here. This ran out sooner than this, even if this happens to be a minus billion, right? This ran out of elements sooner, so this is lesser than this. 1, 2, 3 is equal to 1.0, 2.0, 3.0. Okay. 1, 2, and then a tuple. 1, 2, tuple, and another number. This is lesser, I'm guessing, because it's... Oh, no, not because it ran out, because it's going to recursively check. So it's going to compare 1 equal, 2 equal, then it encounters the tuple, and now it's going to recursively compare the tuple. It's going to check A, and okay, it's going to compare AA with ABC. Okay, and now it's going to recursively go to the string. It's going to compare A and A equal, A and B not equal. This one is lesser, so this whole sequence is lesser. Interesting. Okay, that makes sense. That makes sense. It's going to recursively compare all those things. And that's how lists and all these sequential data structures are lesser or greater. For the Java developers out there, it's an interesting exercise. I want you folks to, if you have time, check out the equals implementation of collection classes, right? How do you define if two collections, like two array lists, are equal? Look at the equals implementation. It makes for interesting reading. Look at compare for, I don't know, not all of these collections have compare. So whatever does have compare, check out the compare implementation, which is how is one collection less than another collection. Again, makes for interesting reading. All right. Note that comparing objects of different types with less than or greater than is legal, provided that the objects have appropriate comparison methods. For example, mixed numeric types are compared according to their numerical value. So 0 equals 0.0. Otherwise, rather than providing any arbitrary ordering, the interpreter will raise a type error exception. Okay, so in this case, if this was instead of 1, 2, 4, if this was a letter, then type error. Right? That's what this is saying. What happens if it encounters a tuple in one list and number or string in the other list at the same time? I'm guessing that's the type error again, because it's different types and it cannot compare. I can try it out. We have it here. Let's try it out. I'm going to comment all this stuff. Let's comment out the prints. And let's say if, or actually print, I'm going to have a, what was that? A tuple and a number, right? I'm guessing it's a type error. So I'm going to say 1, comma, and then a tuple. Tuple, is it less than 1, comma, and then a number? Okay, is it less than? Oh, there you go. Less than not supported between instances of tuple and int. So it basically looked at this. This is a tuple. This is an int. I cannot compare anymore. So it throws a type error. Raise is a type error. That's the syntax. That's the terminology used in Python. You see this? Raise. It doesn't throw, it raises. Okay. With this, we have come to the conclusion of data structures. We've covered Python data structures. Cool. With this, I'm going to wrap up today's session. I hope you found this useful. I certainly found it useful because I was learning Python. And thank you so much to everybody who joined and gave some really useful comments and feedback and helped me when I was messing things up. So thank you for that. I see one question here. Is it a good idea to use Java for machine learning? Uh, Probably not, because you're going to run out of libraries unless you want to implement all of them yourself. I would say just use Python. And Python is fairly simple. You can basically just create a wrapper around, create an API or something like that, and then use it in Java. So you can still code in Java while using a Python layer to do the machine learning part of it, right? So again, thank you. I had fun. I hope you did too. And I'm thinking I'll stream tomorrow. I'll stream tomorrow morning my time. I think. Um, but then it's going to be recorded, so anytime, just hop in and check it out. Thank you, thank you, thank you. Hope you have a nice morning, evening, night. Hope to do a stream on Rust. Well, I'm gonna take on Naveen Reddy's offer. Naveen, if you're still here, we should do it, my friend. Let's plan to do that. It'll be fun. All right, thank you, folks. See you tomorrow.